Hi teachers, Unit 6 is on operations with fractions. So we start with adding, subtracting, multiplying, and dividing, and we also do some order of operations with sign fractions at the end. So let's start with adding and subtracting. So just like we did in number sense 1 when we were talking about integers, and we're going to continue this theme throughout decimal operations, we really want to focus on the idea of using physical representations, symbolic representations, then internalizing or visualizing these representations, and finally abstraction. So again, the idea is some books or in the past you might have just said add 1/5 plus 2/5, and you say add the numerators, keep the denominator, you're done, you have now added. Now instead we'll start with the physical or symbolic, and physical can be manipulatives. You won't always have manipulatives, but at SCC we do have fraction circles that you can use. The symbolic will be these drawings of the physical representation, and then internalizing is when they start to be able to visualize these representations in their mind without actually having to draw them, and then they could generalize these ideas to an abstract reasoning of the operations. Okay, so notice we always start with some sort of application. Here we're going to use the area model. Here we have a number line or a continuous model. And notice the way this is set up. So actually let's look at number 2. So we have 3/8 and we have them right that this is 3 copies of 1/8, where 1/8 is our unit fraction. Then 7/8 is 7 copies of 1/8. And then combined, we'd have 10 copies of 1/8. So again, this idea of the unit fraction as our unit, we could think of 1/8 as cookies. You have 3 cookies, and 7 cookies is 10 cookies. Getting them to see when we add fractions that our unit fraction is our unit of measure. Okay, so again, something students typically do is add the denominators. That's an error they sometimes make, and it seems to make sense because you add the tops, you add the bottoms, you're adding them, so maybe that makes sense. But using this type of language helps them see that the denominator remains fixed. Okay, so area model. Okay, and those ones had common denominators. Then we have a few examples where they have to find a common denominator. Okay, we start with denominators that have only a greatest common factor of 1. Then we look at ones where 1 is a multiple of another. And then we have an example where they have the GCF is greater than 1, and they need to find a least common multiple, or a common multiple, or a common denominator in general. Okay, so we want to build up all these ideas. And notice for each problem it says symbolic representation of the algorithm. So we're building in that abstract component and connecting it to the diagram. So it's not that we're leaving out the abstract and the algorithm, but we want them to have a picture of it, then show how we represent the picture symbolically, and the steps we take to add these fractions without the visual aid. Next we have adding improper fractions and mixed numbers, and we start with improper fractions with common denominators, and showing this idea of how this connects to our original problems. Even though these are improper fractions, it's the same idea. 7 copies of a quarter plus 5 copies of a quarter is 12 copies of a quarter, and they can count those 12 copies along the number line. Then we have examples with mixed numbers, and there's of course two ways they can do this, or probably even more, but here we use the idea of you want to remind them that 4 2/3 means 4 plus 2/3. 3 1/2 means 3 1/2. So we're really combining 4 quantities here. Okay, so if they write it as an improper fraction, which you can have them do, then they can use the same process they used on the previous problem. And then here we want to use the idea, due to commutativity, they can add the whole numbers. They can add the fractional parts separately, so this would be 4 6 and 3 6, so it's 7 6. Okay. And then rewriting this as a mixed number and combining. Sorry, that looks like a plus or minus. Okay, so this idea of regrouping. Okay, and if you use fraction circles for these, there kind of wasn't a lot of room to write the 4 whole circles and the 3 whole circles here, but they can see how you're just regrouping these into a different form. Okay, then let's see. Here's one with a mixed number and an improper fraction. Okay, so here they could see they can go to 2 3/5 and then count 9/5. They can also write this as 13/5 and then count that many fifths and 9/5. So basically there's not one way you want them to do this. You can show it in one way, but it's better if you give them the opportunity to look at this in different ways that make sense to them and then connect those ideas as a class. And now we have subtracting fractions, which is of course similar. Okay, so the day after Thanksgiving there was 3/5 of a pumpkin pie. Lara ate 1/5 of it. How much is left over? Okay, so again with the diagrams here, they're important. So this is a takeaway problem as opposed to a comparison problem, but it can be confusing to them here, or they have to see these different ideas, and I know these are probably horrible, but they're close enough. Okay, so if we have 3/5 and 1/5, okay, when we're using takeaway, we're thinking of taking away that one piece, and our result would be that we have 2 pieces left over. Okay, so this is kind of weird when they see them next to each other. The taking away seems a little bit odd. You want to take it away from the original image rather than write a new image, but it's good for them to see this connection as a series of pieces. Okay. In the second one, we're looking at a comparison model. Billy ran 5/8, Roberta ran 11/8. How much further did Roberta run? And this one in context, it's really more intuitive. Instead of, okay, I'm just going to write these here instead of actually counting them out. So if we thought of this as takeaway, starting at 11/8, we could count down 5/8. That would be 6/8. Okay, but this is really a comparison problem where we want to look at the difference. You can think of it as counting up or counting back from 11/8 to 5/8 and finding this difference. The difference between 11 and 5/8 is 6/8 is another way to conceive of subtraction that makes more sense in this context. So again, back in integers, we talked about these 2 different models of subtraction. And if they always think of subtraction as takeaway and not comparison, it really gives them a myopic view of subtraction. So we want them to see both. And then we follow the same type of steps we did with addition. Here we have greatest common factor of the denominators is 1. They need to cut them into more pieces and subtract. Here 1 is a multiple of another. In each case they're finding the symbolic form. Here they have a greatest common factor of 4. You'll notice in the last addition problem, when they had a greatest common factor greater than 1, the picture ends up being kind of sloppy. They're doing a lot of cuts and it's hard to see where they line up. So here we just have them do the symbolic representation and applying these ideas, and hopefully they'll be able to visualize, well, we cut all the 12s into 2 pieces, that gives us 24. Cut all of the 8 pieces into 3 pieces, which gives us 24. So if you can imagine that, hopefully they can too, based on this idea. They can draw it out, but again, 24 pieces gets a little bit ugly, and then setting it up. Okay, here we have subtracting improper fractions and mixed numbers. So again, connecting that just because they're improper, it doesn't really change the idea of how we're going to subtract here. Here we have mixed numbers, and there is the issue of borrowing. And in the videos, instead of writing out the borrowing, okay, so they could write it. And both ways are useful. It just all depends on what they prefer. And they should know both. So borrow 1, so now this is 4/3. We probably would have changed these to sixths first. This is 8/6, and then they can subtract and get 5/6. Okay. Then there's also the option, which is what I think I did here in general, rewrite this as a mix or an improper fraction first, minus 7/2, then write them each with the common denominator. So if they write them as improper fractions, you don't have the borrowing issue. But they should be able to do both. And I think you'll agree, if they have a problem like 3 and 5/6 minus 2 and 1/6, we don't really want them to go through all the trouble of writing this as an improper fraction when they could subtract it very easily. So we want them to see both ways and connect the ideas. And again, it's a good discussion for them. When would you want to write it as an improper fraction? When is it worth it? And when is it just extra work? And here we have number lines as our diagrams. And that sums up subtraction. So in the next video, we'll look at multiplying fractions.